In this video, we are going to look at the CSEC Math June 2019 Paper 3. So here we have our first question where we have a company employs 10 unskilled and 8 skilled workers, and they produce two models of toys, all right? Model A and Model B. So Model A requires 20 hours of unskilled labor, while Model B requires 15 hours of unskilled labor. And Model A requires 10 hours of skilled labor, while Model B requires 25 hours of skilled labor. So now they're saying that each worker provides a maximum of 40 hours of labor per week. So here we want to calculate the maximum number of hours available per week, all right, for unskilled labor. And that's simple because you have 10 unskilled workers to provide unskilled labor, right? And we're working a maximum of 40 hours per week. So the maximum hours per week would just be the 10 times the 40. And the same thing for the skilled labor, right? The skilled labor, we have 8 skilled workers, all right, providing a maximum of 40 hours per week. So 8 times 40 will give you a maximum hours for skilled labor. All right, so part 1, all right, max hours per week for unskilled labor is equal to the 40 hours times our 10 workers, which is the unskilled workers. So 40 by 10 is 400. All right, 400 hours. And for the skilled labor, right, is equal to the 40 hours times the 8 skilled workers that we have. All right, so 40 times 8. And 40 times 8 is 320. So we have 320 hours max for skilled labor. So now let's look at part B. Assume that the factory makes X model A and Y model B toys per week. Show that the inequalities for the hours of labor are: for unskilled labor, we have 4x plus 3y is less than or equal to 80. And for skilled labor, we have 2x plus 5y is less than or equal to 64. Now notice these inequalities combine the number of model A toys, which is x, and the number of model B toys, which is y. So if you go back to our previous page here, where you have this information, we'll see that model A requires 20 hours of unskilled labor. Now remember, we know the maximum amount of hours for unskilled labor is 400 hours, right? Now that will be both for model A and for model B. That's the total amount of hours for unskilled labor, which is 400 hours. So the maximum amount of hours for unskilled labor for model A only will be the number of model A toys, which is x, times the hours required, which is 20. So 20 times x will give you the maximum amount of hours for unskilled labor for model A. All right. And for model B, unskilled labor as well, the number of model B toys is y, right? And you have 15 hours. So 15 hours for 1 times the number of model B toys, which is y. So 15 times y will give you the maximum amount of hours of unskilled labor for model B. So when you combine the two, the 20x, which is for model A, and the 15y, which is for model B, it must be less than or equal to the 400 hours for unskilled labor, because this is your max. You can't cross 400 hours for unskilled labor. So coming back here, I'll write the 20 times x plus the 15 times y must be less than or equal to 400. Now, if you look at both sides of this inequality, we realize that these numbers are divisible by 5, right? 5 we're going to 20. So let's divide both sides by 5. So I'm going to divide by 5. All right. So divide 20 by 5 and we get 5 4s are 20. So 4x. All right. Divide 15 by 5 and you get 3. So 3y. All right. Less than or equal to. Divide 400 by 5 and that is equal to 80. All right. And there you have this inequality here. Now for the skilled labor, we're going to do the same thing. All right. So let's go back to the previous page. Let's read the information for the skilled labor here now. So model A, remember you have X model A and the number of hours for one model A toy is 10 hours, right? So 10 times the number of model A toys, which is 10x, will give you the maximum amount of hours for the skilled labor. All right. And model B, we have Y is the number of model B toys, right? So 25 hours for one. So 25 times the number of model B, which is 25y, right, will give you the maximum amount of hours to make model B. Now combining the and that's for skilled labor, right? So combining the maximum hours for Model A skilled labor and the maximum hours for Model B skilled labor, it cannot cross 320 hours because this is the maximum amount for skilled labor, right? 320 hours. So it must be less than or equal to 320. So what we're going to have here, 10x plus 25y must be less than or equal to 320. So I'll write that 10x plus 25y must be less than or equal to 320. And again, if you look at both sides of the inequality, these numbers are divisible by 5. So let's put divided by 5 here again. All right, so if I divide 10x by 5, I would get 2x. If I divide 25y by 5, I'm going to get 5y. And if I divide 320 by 5, I'm going to get 64. And again, you prove your inequality. Same thing here. Get it here. All right, so that was part B. Now for part C, they wanted to show by calculation that it is possible to make 15 Model A toys and 5 Model B toys. All right, so remember, X is the number of Model A and Y is the number of Model B. So if you look at the two inequalities that we proved, all right, if you replace the X with 15, because X is Model A, 15 is Model A, 15 Model A. So replace both of them. In both of them, X is 15. And for Y, you replace it with 5 in both of them. What you get on the left-hand side here must be less than or equal to 80. What you get on the left-hand side here must be less than or equal to 64. So let's prove that now. Show by calculation is possible. All right, so I'll start with the first one where 4x plus 3y is less than or equal to 80. All right, so again, replacing the, there's some little shade in here. All right, so let's remember the x is Model A and the y is Model B. All right, so we're going to have 4 times x, and x is 15, plus 3 times y, and y is 5. And that must be less than or equal to 80. All right, so we're going to have 4 by 15 is 60, and 3 by 5 is 15. All right, less than or equal to 80. And 60 plus 15 is 75. So 75 is less than or equal to 80. So this statement is true. All right, therefore it is possible to make 15 Model A toys and 5 Model B toys. So this is for the, remember this equation here is for the unskilled labor. So this is possible with unskilled labor, right? So this is for unskilled labor. All right, so what I did here, I just labeled this one for unskilled labor. This was the work in here. And I wrote since 75 is less than or equal to 80, which is true, right? It is possible to make 15 Model A and 5 Model B toys with unskilled labor. So now we need to prove it for the skilled labor. All right, so I have for skilled labor, remember using the 2x plus 5y is less than or equal to 64. All right, so replacing the x with 15 because we have 15 Model A toys, and replacing the y with 5 because we have 5 Model B toys. All right, and we must show that this is less than or equal to 64. So 2 by 15 is 30, and 5 by 5 is 25, less than or equal to 64. And when we add 30 and 25, we get 55. And this statement is true, right? 55 is less than or equal to 64. All right, so I have, since that 55 is less than or equal to 64, it is possible to make 15 Model A and 5 Model B toys with skilled labor. So therefore, it's possible to make the 15 Model A and 5 Model B toys with unskilled labor and also with skilled labor. And we prove that here and here. Now moving on to part D, we are saying that the factory makes a profit of $40 on a Model A toy and $60 on a Model B toy each week. Now we want to write an equation for your total profit. So your total profit will be P per week for making X Model A. So X is the number of Model A toys. And if you stop us right here, so you have X is the number of Model A toys. And you're making a profit of $40 on one Model A toy. So the total profit for Model A will be the $40 for 1 times the number of Model A toys, which is X. So that's 40 times X is the total profit for Model A. Now moving on, and Y is the number of Model B toys. So the profit for one Model B toy would be $60, and Y is the number of Model B toys. So if you multiply the number of Model B toys by $60, profit for one, you'll get the total profit for the Model B toys. So that's 60 times Y, which is 60Y, total profit for Model B. Now if you add those two together, so P is total profit, because it's telling you that the total profit, the symbol for it is P, all right, is equal to the total profit for Model A, which is 40 times X, and the total profit for Model B, which would be 60 times Y. And now for part 2, they say, what is the profit to the company when it makes 15 Model A? So 15 is the number of Model A. So let's write all the total profit again. So P is equal to 40 times X plus 60 times Y. All right, so X is the number of Model A, and Y is the number of Model B. So we have 40 times X, and X is equal to 15, because we have 15 Model A toys. And then 60 times Y, and Y is equal to 5, because we have 5 Model B toys. So we have total profit is equal to 40 times X, which is 15, plus 60 times Y, which is 5. So our total profit is equal to 40 by 15, which is 600, plus 60 times 5, which is 300. Add those two things together and we get 900. All right, so that's $900 would be our total profit. All right, so part E, they want to show that the profit calculated in D part 2. So that's the profit calculated here, which is $900. And that was for 15 Model A and 5 Model B toys. We want to show that that 900 is not the maximum profit. So I want to recall that for the hours for unskilled labor, we had this inequality, 4x plus 3y is less than 80. All right, so going back here, unskilled labor, 4x plus 3y is less than 80, and that's what dealing with the hours. All right, for the unskilled labor. And for the skilled labor, we had the 2x plus 5y is less than or equal to 64. And that was dealing with the total number of hours for the skilled labor. So the total amount of hours for the unskilled labor must satisfy this inequality, and the total amount of hours for the skilled labor must satisfy this inequality. Now notice here when we worked out it was possible to make 15 Model A toys and 5 Model B toys, right? For unskilled labor, we had 75 is less than or equal to 80, which means this 75 didn't reach its maximum of 80. So it's possible that we could probably manufacture some more toys using unskilled labor because we're still under the 80. And across here for skilled labor, we have the 55 is less than or equal to 64. So again, it's possible to make some more toys using some skilled labor because we didn't reach our maximum of 64. Now, this is a 1 mark question, right? So let's look at the number of marks. You're not going to do no big set of work in here. All right, I just want to show that that $900 here is not the maximum profit. And as we said, we are leaving some toys on the table for unskilled. We didn't reach our maximum of 80. We only reached 75 when we worked 15 Model A and 5 Model B. And for skilled, we didn't reach our maximum of 64 when we did the 15 Model A and 5 Model B. So it's possible that we can make some more Model A or some more Model B toys. All right. So all I'll say is either I bump up the Model A by that's 1 or the Model B by 1, and let's see if it's possible. All right. So if you want to say, okay, let's try 15 Model A and let's say 6 Model B and see if it's possible. So what I have here, let's see if it's possible to make 15 Model A toys. So that's the standard 15 that we was using all the time, but let's bump up the Model B toys by 1. So instead of 5 Model B, let's see if it's possible to make 6 Model B toys. All right, so let's first satisfy the equation for unskilled labor and then skilled labor. All right, so for unskilled labor, we have 4x plus 3y is less than or equal to 80. So X is the number of Model A toys and Y is the number of Model B. I'm using 15 for Model A and 6 for Model B. All right, so 15, replacing the X with 15 and the Y with 6. And let's see if that's less than or equal to 80. So 4 by 15 is 60 plus 6 3s are 18. So let's see if that's less than or equal to 80. All right, so when you add these two together, you're going to get 78. and we haven't crossed, so we haven't crossed eta, all right? So it is possible to make an extra model B toy, right, using unskilled labor. Now let's check for skilled labor. So for skilled labor, we have our inequality again, the 2x plus the 5y is less than or equal to 64. Remember, x is the number of model A and y is the number of model B. So we're going with 15 model A toys and 6 model B toys. So we'll have 2 times x, and x is 15, plus 5 times y, and y would be 6, less than or equal to 64. Let's see if this is true. All right, so 2 times 15 is theta, and 5 times 6 is theta, which is less than or equal to 64. Right, so theta plus theta is 60. And this statement is true. So it is possible to make the extra model B toy using skilled labor. All right, so it is possible to use unskilled labor and make the extra model B toy, and it's possible to use skilled labor to make the extra model B toy. Right, so now let's look at the profit. Obviously, using 6 model B, we're going to get a greater profit than the $900. So for profit now, our total profit P is equal to 40 times x plus 60 times y. All right, and remember you're replacing your x with 15, which was the standard thing, but we increased in the model B now by 1, so instead of 5, using 6. So the 40 by the 15 will give you the 600, and the 6 by 60 will give you 360. So when we add that up, we're going to get our total profit would be $960. All they wanted us to do here was to show that the maximum profit calculated in D part 2, the total profit of $900 was not the maximum. All right, so we see that we could get a profit of $960 by making an extra model B toy, and we have the amount of hours of unskilled and skilled labor to make the extra model B toy. All right, which will give us a greater profit. So therefore, we have answered this question. All right, so I just want to throw in the statement, hence it is possible, meaning that when I ask this question, let's see if it is possible to make 15 model A and 6 model B toys. So once you do this work in here and say that 78 is less than or equal to 80, which is true, and the 60 is less than or equal to 64, which is true, means it is possible, right? So hence it is possible, all right, to make the 15 model A and 6 model B toys. And then we work out the profit and show that, you know, it's more than the 900, so our maximum profit was not the 900. So now we have question 2, where we have a diagram not drawn to scale, shows a flexible piece of card in the shape of a sector. All right, so you know a sector, this would be like the center of the circle, and this would be radius, and this will also be radius for this to be a sector, right? So if here's 18, then here's also 18, because R to O is the radius, and O to P will also be the radius. All right, so here will be 18 centimeters. All right, so the telling us that the center is O, which I already said, and the radius is 18. All right, so they want us to use pi as 22/7, and they want to show that the perimeter of this card is equal to 80. So we have the 18 and the 18 here. We need this length of arc here from R to P, and then we can add the 3 distances up, and that will be the perimeter. All right, so now we have to find the length of the arc RP. So I'll say length of arc, and that's RP, is equal to the circumference of a circle, which is 2 pi r times the angle theta over 360. All right, so that angle theta is this 140 degrees here. All right, I'm using pi as 22/7, right? So we're going to have, this is equal to, I'm going to put it 2/1, all right, times pi, and using pi as 22/7, times the radius, which is 18, so I put that over 1, times theta, which is 140 over 360. Now remember, you can use calculators for this paper 3. So you don't have to fight up to take too much time canceling. I mean, yes, you've seen stuff get cancelled, right? 2 could go into 2, 1, and 2 could go into 360, right? 7 could go into 140. So we could cancel, but why do all that when you can use a calculator and just do it fast? All right, so I just pulled my calculator up, so I can multiply across with the numerators, and let's multiply 2 by 22 by 18 by 140, and then multiply the denominators, which is 1 by 7 by 1 by 360, and then, you know, divide them. All right, or I could just put the whole thing into the calculator. All right, instead of putting 2/1, I'll just put 2, right, multiply by pi, which is 22/7. So for this one, I'll put 22, use the fraction button, over 7. All right, multiply by 18. All right, and then multiply by 1/4 over 3/6. So 1/4, use the fraction button, over 3/6. Just like that. See, easy. Press equal, and we get 44. All right, so we get the length of the arc is 44 centimeters. So now the perimeter is equal to the 18 plus the 18 and plus the 44. And that will be equal to your 80 centimeters. All right, so you show that the perimeter is equal to 80 centimeters. We have shown that. Now for part B, they want us to calculate the area of the card, which is the sector here, right? So the area of the sector, they want us to calculate the area of the sector. So we're going to go area of sector is equal to the area of a circle, which is pi r squared, times the theta over 3/6. So again, they want us to use pi as 22 over 7, so 22 over 7 times the radius squared, which is 18 squared, times theta, which is 1/4 over 3/6. And again, we can just do that on the calculator. All right, so for pi, I have 22 over 7, so 22 put over 7 like that. Multiply by 18 squared, so multiply by, open brackets, 18, close brackets, and squared like that. And then multiply by 1/40 over 3/6, so 1/40 put over 3/6, all right, and let's press equal sign, and we get 396. So we have 396, and that'll be centimeters squared. All right, so for part C, we have that the card is bent and the edge is OP, so that's OP here, which is the radius, and OR are taped together, so OR is here, so that the card forms a curved surface of a cone. So you know the net of a cone is a sector, and of course the base of the cone is a circle, right? So, and this sector for the net of a cone, the length of the arc of the sector is equal to the circumference of the circle, and the radius is equal to the slant height of the cone. All right, so here's my attempt to draw the cone where we have the circular base. All right, so R will be the radius of the circular base, H will be the height of the cone. And remember, I told you that the radius here of the sector is the slant height. So what we're going to have here is that the slant height is equal to the 18 centimeters. Now for part 2, we want to calculate the radius of the circular base of the cone. So that's the circular base of the cone where the radius is R. And the circumference of the circular base of the cone is equal to the length of the arc RP. Well, the length of the arc for the sector RP. So I wrote that the circumference of the base of the cone, that's this, is equal to the length of the arc RP. And if we go back, we'll see that the length of the arc RP is equal to 44. So I'll have the circumference of the base of the cone, circumference of a circle is 2 pi r. And that's equal to the length of the arc RP, which was 44. All right, so now that's putting in that pi is 22 over 7. We'll have 2 times 22 over 7, which is pi, times the radius r, is equal to 44. Now, if we simplify this here, we can write this as 2 over 1 multiplied by 22 over 7 multiplied by r over 1 is equal to 44. Multiplying across, we can multiply 2 by 22, which is 44 times r. So we have 44 r over 1 by 7 by 1, which is a 7, is equal to 44. And I'll put this 44 over 1 time. So we can just cross multiply. So we multiply 44r by 1, which will just give you 44r. And 7 by 44, let's write that as 7 times 44. All right, I wouldn't work it out just yet because I've seen it's easy to work out because I've seen this 44 here and this 44 here, right? So I'll just leave it like this. And when I transfer this 44 across the equal sign, the operation will change from 44 multiplied by r to division. All right, and we'll have r is equal to 7 times 44 divided by 44. And that's why I left it like that, because I've already seen that these 44s will cancel. All right, and just remember the 7. So r is just equal to 7 centimeters. All right, so that's the radius of your cone, 7 centimeters. So for part 3, they say using Pythagoras theorem or otherwise, we want to determine the perpendicular height of the resulting cone. All right, so that's this height here. And of course, this is a right angle triangle. So if we want, we can draw that triangle separate. All right, we have the 18 centimeters here, and we just found that this radius here, R was equal to 7. That is this radius here. All right, so this here is 7 centimeters. All right, so let's put in 7 centimeters here. All right, so now that here is 7 centimeters, so that's what I have here, 7 centimeters, right? So now if you have to draw a line from the right angle, we'll touch this side here. All right, and therefore this 18 would be hypotenuse, right? The hypotenuse is always the side opposite the right angle. All right, so let's draw a line from the right angle to touch the hypotenuse. All right, so this is your hypotenuse. This is your height here, h. All right, so Pythagoras theorem states that the square on the hypotenuse is equal to the sum of the squares on the other two sides. All right, so we have 18 squared. Square on the hypotenuse is equal to, the other two sides is h and 7, so 8 squared plus 7 squared. We transfer this positive 7 squared across the equal sign, I will turn to negative 7 squared. So we'll have 18 squared, take away 7 squared is equal to 8 squared. To get rid of the square and the h, we'll take the square root, all right, of the 18 squared, take away 7 squared, right, and that will be equal to h, the height. All right, so height is equal to, all right, okay, let's go on the calculator and work that out. So that's square root of, open brackets, and I'm going to put the 18 squared, so 18 squared, take away 7 squared, and then close the brackets, all right, equal to, and that's 16.58, let's write that as 16.6 to 3 significant figures, 16.6 centimeters. And that's it. That's the end of the test.